JMath.
Welcome to the video for the practice questions on general solution. So please look at the questions that's going to be in this video, pause it right here, and then try them, and then we can mark it together and see how you did. If this was a class test, how much would you have gotten for this class test? Question 1. So the first thing I need to do is I need to get sine 2 theta alone. So I'm going to say sine 2 theta is equal to minus 3, and I'm going to divide by that 4. Okay, so now sine 2 theta is alone, so I can go for the quadrant. So I can see it's negative. So it's negative in quadrant 3 and in quadrant 4. So the reference angle, in this case, I will get if I say shift sign of 3 over 4. So remember, I only use the minus to identify the quadrants, but the reference angle is always positive. If I type that on the calculator, it tells me it's 48.59 degrees. So now I can write down the solution. So in quadrant 3, I know that 2 theta is going to be equal to 180 plus the reference angle, plus K360, and then K is an element of Z. Okay, so now I'm just going to simplify. So I know that 2 theta is going to be equal to 228.59 plus K360, and then just divide by 2. Also remember to divide the 360 by 2 to get K, 180. So that's the answer for quadrant 3. And then for quadrant 4, I'm just going to say, okay, 2 theta is also equal to 360 minus the reference angle, plus K, 360. And then if I simplify that, I will just get to 311.41 plus K, 360. And then I just half it, and then I get theta is equal to 155.70 plus K, 180. Okay, so now normally I would be done if I get to this step, but they told me that theta is an element of minus 180 to 180. So when they give me that part, it means it's specific solution. And that's the part that I always urge you to do with the table method on your calculator. So in this case, I would say mode, table, fx would be the 114.3 plus k180, but in this case, you're going to say plus 180 alpha x to save it into the fx part. Then I'm going to save the right-hand side into the gx part. If I press equal, then it would say start. I would say minus 3, end at plus 3, and then step is 1. Then you can see these are the answers they give me, but I'm only interested in all the ones that's between minus 180 and 180. So the final answer would be, and then I can just leave it like that. That is then the specific solution. This question would be 5 marks because there's so many methods you could follow. They only give a mark for your answer for quadrant 3 and for quadrant 4. So a mark for doing it correctly and then a mark for simplifying as far as possible. The last mark is for your specific solution. For question 2, I now have a sine on the one side and a cos squared on the other side. When this happens, I need to think, what can I change? So I can't change sine theta, but I can change cos squared theta. So that's exactly what I'm going to do. So I can simplify it as sine theta plus 2, and then I'm going to bring this to the left, minus 2, and then in brackets, my grade 11 formula tells me this is 1 minus sine squared theta is equal to 0. So now I'm going to multiply that minus 2 in, and that's going to tell me it's sine theta plus 2 minus 2 plus 2 sine squared theta is equal to 0. The 2 and the minus 2 cancels out, and then I can actually take out a common factor. So sine theta, and then what's left in the bracket would be 1 plus 2 sine theta. Now I can do general solution with both of those factors. So on the one hand, I'm going to say sine theta is equal to 0, and then on the other hand, I'm going to say 2 sine theta is equal to, and I'm taking the 1 over, so therefore sine theta is equal to minus a half. Now I do general solution for both of these. So remember, whenever it is just sine or cos or tan equal to 0 or equal to 1, I can use special angles or just the graphs. So if I draw the sine graph, it would look like this. And it's 0 at 0 degrees and at 180 degrees. So my answer there would just be theta is equal to 0 plus k 360, or theta is equal to 180 plus k 360. So if I use the graph, I don't need to do quadrants and reference angle. But if you feel you're going to forget that, just do the normal quadrants, reference angles, you will get to this exact spot. Okay, but we also need to solve the other side. And I can see the quadrants where sine is negative would be quadrant 3 and quadrant 4. My reference angle would just be shift sign of a half, and that would tell me it's 30 degrees. So in quadrant 3, I can say theta is equal to 180 plus 30 degrees plus k 360, and then it's just theta is equal to 210 plus k 360. In the fourth, it would then just be theta is equal to 360 minus 30 plus k 360, and final answer would then be 330 plus k 360. Okay, so you would notice I forgot something, so I must just somewhere in the sum, I must just write k is an element of z. And for that, I will get full marks. This sum would be 5 marks, so a mark for the cos squared that you changed, a mark for the factorization, then a mark for the answer for sine theta equal to 0, and then 2 marks for the general solution of the other side. Question 3 can be seen as an advanced sum because there's something hidden in this question that if you haven't practiced this, it's not something you would just logically think of in an exam. So let me show you that they can never catch you out with this one. First thing, I'm going to move everything to the left. So the cos squared theta I'm going to leave there. I'm going to bring the 7 sine theta cos theta to the left. And then I'm left with the plus 2. Now, the part that you must now see is that I have a cos squared. I can change it to 1 minus sine squared, but that's not going to help me because the middle term has a sine and a cos. Whenever that happens, I want sine squared and cos squared in the sum. And the only way to get it is if I say this 2 is multiplied by 1. And remember my identity, 1 can also be written as sine squared plus cos squared. So I'm just going to change that 1 into sine squared theta plus cos squared theta. So then my second line would look like this. So that gives me a trinomial, and now I can solve the trinomial in any way that you are comfortable with. You can use the calculator, you can use the quadratic formula, just get the brackets. So in this case, this would be 3 cos theta, and I know the other side is just going to be cos theta. Then I know I'm going to end off with a sine theta in both brackets, but I need to place that 2 somewhere. So the 2 actually goes at the back, and the signs are pluses. So how do I know that? If I multiply these two, I will get 6 sine theta cos theta. If I multiply those two, I'll get 1 sine theta cos theta. 1 plus 6 gives me a 7. Now that I have the 2 brackets, I can now just say each bracket is equal to 0. So 3 cos theta will be equal to minus sine theta. And the other one, I can just say, okay, so 2 sine theta is equal to minus cos theta. So I'm just shuffling things around just to save a step, but you're welcome to write down every single step if you need to. So on the left, I cannot do general solution if it looks like that, but I can divide by cos theta. So in this case, if I say sine theta divided by cos theta, that would give me tan theta. And I'm just moving the minus to the other side so that it's easier. In the other one, I can again divide by cos theta to change it to tan theta. And then on this side, I have a minus 1 left over, and I'm going to divide by 2. Okay, so now I have 2 equations that I can actually do general solution with. Once again, we're at tan theta. So you are welcome to do both quadrants, or you can just do one quadrant because it is tan. You can just ask your teacher what she's going to mark correct, but in the finals, they will mark it correct if you just do one quadrant for tan. So if I look at the left-hand side, my quadrants are going to be where tan is negative, so it's quadrant 2 and 4. And then my reference angle would just be shift tan of 3. And if I type that in my calculator, it tells me it's 71.57. So the answer for this question is in quadrant 2, theta is equal to 180 minus 71.57 plus k 180, and it simplifies to 108.43 plus k 180. I can just put the k element of z right there, and now I can move over to the other sum. So for this, my quadrants are going to be 2 and 4 again, and my reference angle will just be shift tan of a half. And my calculator tells me that is going to be 26.57 degrees. So this one's answer will then be, for the second quadrant, theta is equal to 180 minus 26.57 degrees plus k 180. And that just simplifies to theta is equal to 153.43 degrees plus k 180. There we go. That's the answers that they want for this question. This question would be a minimum of 5 marks, so 1 for seeing how to start this question, then for simplifying your trinomial, for factorizing your trinomial, and then for the 2 general solutions at the very end. Question 4 is actually the easiest one in this video, but let's see what we would do. So in this case, it's classified as an advanced trig equation because I won't be able to shift tan anything in this case. So I can immediately go into the quadrants. So I can see tan is positive on both sides, so it's quadrant 1 or quadrant 3, and my reference angle is actually the right-hand bracket, so 30 plus theta. Okay, so if you're unsure about this, please just go check the video on advanced general solution, and there I explain all the steps for this. In this case, if I go for quadrant 1, I don't need to start with the left-hand bracket, so 2 theta minus 60 is equal to, it's quadrant 1, so it's 0 plus the reference angle, which is just 30 plus theta plus k 180. So therefore, if I move all the thetas to the left, I have 2 theta minus 1 theta, just gives me a theta, and 30 plus 60 is 90, plus K180. And that is the answer to the sum. So it would only count 2 or a maximum of 3 marks. So for question 5, I can immediately spot there's 2 thetas and there's 2 60s in this. So that tells me it's compound angles. And if I look at the format and look at my identities, I can spot it's sine, cos, sine. That tells me it's a sine compound angle. And with sine, it always stays the same. So this would be sine of theta minus 60. Okay, so I don't need to write anything else. The first mark for this question would be for that step. And then they told me this is equal to minus cos 10 plus 2 theta. Now I need to decide, do I want to work with sine or do I want to work with cos? Any one of them is perfect. In this case, I'm just going to work with sine. So I'm going to do a cofunction on the right-hand side. So I'm keeping the minus, but this would be sine and then 90 minus 10 plus 2 theta. Okay, just to simplify it a little bit. So that's theta minus 60 equals to minus sine. And then 90 minus 10 gives me 80 minus 2 theta. Okay, perfect. I can see there's a negative. So my quadrants in this case would be 3 and 4 because I'm working with sine. And then the reference angle would just be the right-hand bracket. So 80 minus 2 theta. So in quadrant 3, I start with the left-hand side. So theta minus 60 is equal to 180 plus 80 minus 2 theta. I can put a bracket there, but it's a plus in front, so it's really not going to matter. So to simplify this then, I can just say this is theta minus 60, and that's going to be 260 minus 2 theta. I'm going to bring the theta to the left, so it's then 3 theta, and that is 320. Just remember to add the K360s. Okay, and then in simplest form, this would be theta is equal to 106.67 plus K120. That's it for quadrant 3. And then in quadrant 4, it's going to look exactly the same, but I'm going to use 360 minus instead of 180 plus. So 360 minus, then brackets 80 minus 2 theta plus K360. So I'm going to bring all the thetas to the left. So that would be theta. On the right-hand side, if I multiply the minus in, it's a positive. So if I bring it over, it's a negative 2 theta. And then on the other side, this would just be 340 plus K360. So now I'm left with a minus on the left. I don't like that, so I'm just going to divide by the minus. So then that's going to be minus 340. And then like we discussed in the previous video, you can make this a minus or you can keep it a plus. It's something that I add extra to the sum. So it defies algebra rules a little bit, but it's really up to you if you want a plus or a minus. And there we go. That's the answer to that sum. This sum would be a minimum of 5 marks, a mark for the compound angle, for the cofunction, choosing the correct quadrant and reference angle, and then a mark for the final answer of each quadrant. So 5 marks for question 5. Question 6. So now I have double angles and I have single angles. That can't work. So I need to do something so they are all similar. I can't change the single angle, so I'm going to have to change the double. I now have 3 options. It's not going to help me to introduce an extra sign into this. So I'm going to choose the option that only has a cos in it. So 3 and then 2 cos squared theta minus 1. I'm going to bring everything to the left. So minus 13 cos theta plus 9 is equal to 0. Okay, so just simplify that a little bit. So this is 6 cos squared theta, and then minus 13 cos theta. And then if I multiply the 3 into that bracket, I have a minus 3, and there's a plus 9, so that gives me plus 6 equals to 0. Now, this is a trinomial. Once again, do it any way that you feel comfortable with, but the brackets in this case are going to be 3 cos theta minus 2, and then 2 cos theta minus 3 equals to 0. Now I need to split and make each bracket equal to 0, so this one would just be cos theta is equal to positive 2 over 3, and then or, in this case, cos theta is equal to positive 3 over 2. So now I can do quadrants. So quadrants, cos is positive in 1 or 4. My reference angle, I get if I say shift cos of 2 over 3. And my calculator tells me that's just going to be 48.19 degrees. Okay, so now if I solve this, in quadrant 1, theta would just be equal to reference angle, so 48.19 plus K360, and then K is an element of Z. That's it for quadrant 1. For quadrant 4, it's just going to be theta is equal to 360 minus 48.19 plus K360, and that just simplifies to 311.81 plus K360. Okay, so now I also just need to look at the other answer that I got. Cos theta is equal to 3 over 2. So now I can see it's positive and whatever, but the reference angle is going to give me a problem. So if I say my reference angle is shift cos of 3 over 2, if you type that in, it's just going to say math error. So remember, if I shift cos or shift sine, the number in the bracket is never allowed to be bigger than 1. Okay, so it must always be 0, comma something if I convert to decimals. This is 1.5, and a cos graph never goes up to 1.5. So therefore, I can just write there big, no solution. Because it's asking you for which x values will the y value of a cos graph reach 1.5. Remember, a cos graph looks like this. Maximum is 1, minimum is -1. So therefore, it never reaches 1.5 for a standard cos graph. No solution. This question would be 6 or 7 marks. You'll get your first mark for the double angle, then for getting the right trinomial, for getting the correct 2 answers, and then for your general solutions for each of those answers. So how did it go with these questions? If I add all of them, it counted out of 30. So if this was a class test out of 30, how much would you have gotten? Are you happy with your mark, or do you need extra work? So please just keep on practicing, and I know it will go well in exams.
If this video helped you, please like and subscribe.
JMath.